Hey guys, Lissandro here, and today I wanted to do something something interesting. So pretty much, I don't remember where. I think it was on this channel that I said that I have a bunch of interesting scientific and philosophical concepts and things like that. But today I was thinking about something. Um, We all know that if you go out into space, you cannot breathe because it's a complete vacuum. There isn't how do you say there isn't any atmosphere any air to breathe or anything. And the reason why is because there's no force to hold it together. And what I want to get at is this. Picture, for instance, that the Earth, like kind of like a glass of water. Okay. If you get and for for demonstration purposes, let's say this is a large glass of water that it holds several gallons and all. Okay, and the thing is, you decide to chunk a bunch of stuff: rocks, dirt, paper, uh, liquids, and all sorts of different things. And you decide to stir it up. Okay, it may be a huge mess, but after a while, things will start settling down. And what will happen is pretty much the heavier stuff will sink to the bottom. Then afterwards, the less heavier stuff, another layer, and then it'll be like a progression from the most heaviest stuff at the bottom to the most lightest stuff at the top, all the way till you get to the surface of the water. Okay, so what I'm trying to get at, the Earth is very similar in a way. Okay, and keep in mind that I didn't include like external forces or intermolecular forces when I gave the example of the water container. It's better you said a water container. Okay, in the Earth is pretty similar because to start off you have all the lighter particles at the higher upper altitudes of the atmosphere. That's usually your gas, nitrogen, and maybe some like denser particles. But the thing is that some of the gases that tend to escape the atmosphere are mainly hydrogen and helium. Why? Because they're very light. There isn't enough gravitational force to sustain them in there, and they generally escape from the atmosphere. But then, as you go down, you get into like, for example, this is of course not considering the ozone layer at all. But as you go further down, you get into much more denser gases, and of course, you have to consider, for example, like temperature, volume, densities, and the uneven distribution of temperature and mass that's in the entire globe. It's not uniform, and of course you also have to consider like for example air currents, things like that, evaporation. There's so many factors. It's not exactly the same as a water contain like the water container I just mentioned, but there's a lot of similarities to it. Oversimplified, yes, it's the same, but identical, no, it's not. So anyway, getting back to the point, as you go further down, then you start getting into the layers of um, pretty much the layers of Earth. You have like your sands, your dirt, rock, and everything. And like I said, it's not because of the fact that not everything's not uniform. And for those of y'all who don't know, the Earth is not completely spherical. It's kind of like shaped like a in a in a way, if you were to graph the entire topology of the topographical topographical aspect of every bit of the Earth, you would get a shape kind of similar to an asteroid, uh, and and because of that, you don't get an even distribution of of the example that I gave with the container and all. But for the most part, you get like your lighter materials coming from progressing from the top all the way to the bottom. In this case, all the way to the center of the core, and all. And the thing is that then after you pass the crust and everything, you start getting into like, for example, you start getting into like much denser elements. Like for example, you start getting to like like iron, nickel, and much denser, and of course you start getting into much more denser elements like such as not plutonium, but uranium, and other stuff. But anyway, the thing is that um, because the Earth is not like, because all the mass is not evenly distributed, um, you occasionally get some lighter elements more upper to the crust than others, but for the most part, heavier elements are more in the um, more approaching the mantle and the core, the outer mantle and the inner mantle. And the interesting thing about it is that as much as people would like to think it's a liquid, it's not. And the reason why is because the force of gravity has so much force on it that let it um, it does not let it be a liquid. The only time you see it a liquid is when you have like pressure, volcanic eruptions, things like that, when it escapes into the Earth's crust and all. And of course, that's a little bit on geology. I'm not an expert on geology, but it's just a simplified aspect. And of course, it keeps going all the way till you get to the very core of the Earth. And they say it's nickel and iron, but my own personal perspective, I suspect that deeper within that nickel iron core, there might be much more denser minerals. I don't know, to be honest, but the thing is that the thing is, for the most part, there's like much denser materials in the center of the earth, and that's also constitutes the reason why there's like radioactive decay and things like that, because they're generally the much denser elements like uranium 238 to 35 and so on. But anyway, I was just pretty much giving that example. What I'm trying to get at is this, and this, we don't currently have this technology or anything, but pretty much in a hypothetical sense, the ability to alter gravity, just like you can alter electromagnetic radiation, and we have no idea how we can approach that. Just like we have no idea how can we approach like the supposed manipulation of time. There's some that believe that time doesn't exist. That's a man-made concept. But anyway, that's another conversation for another time. The thing is that the thought that I had in mind is kind of it's actually two concepts, and pretty much it's the thought of one of them is the thought of a selective type of gravital control in which you can decide which what do you call it, which elements are affected by gravity and which are not, to whatever alteration you're going to do to gravity. And think about it this way: let's say you're out in space, and you're out in space. You have, let's say, like in sci-fi movies, you manage to have a gravity generator to keep everything in place. To be able to walk normally. Okay, and of course, you have to keep in mind one thing: matter has like gravitational force. The only thing is that something equally as massive as we are, or less, is not going to have that much force as you would on planets. But the thing is, let's say you manage to get a gravity generator, okay, and the way this would play out is that uh, you would have normal gravity, but even if you let out an atmosphere of oxygen or breathable gas, which is 21% oxygen and the rest is like 78% nitrogen and other gases, that gas would dissipate into space. You would have to have a containment, and it kind of that's part of the problem with atmospheres and things like that. Okay, now how would you go about doing a system in which you don't require any windows, containments, or anything like that? If you were to create something in which you could alter gravity, in which everything else would have normal gravity, but the gas would have like probably 5 or 10 times more gravity, all depending uh, all depending how to pretty much get a sustainable atmosphere in space, then you would have something very interesting to go by. But of course, this is only a hypothetical concept. There's a lot of things to consider about this because, in essence, like I said, we don't even have the technology to even alter gravity or anything. We don't have nothing like that, like alter the gravity of planets or mass itself. And but anyway, um, I'll try to see if I can do like a visual representation of what I was talking about, because normally people understand like concept better if they're visual rather than if they're auditory, you know. And the thing is that the problem with that is that if I take a long time to do animation on my stick gibberish and scribbles channel, it's gonna take me equally the same amount of time to create the animations for these demonstration videos and all. But anyway, I hope I explained a little bit of what I was talking about. Oh, and before I go on, there's the second concept I was talking about. The second concept of like application of manipulation of gravity is pretty much this. You know how like a lot of the times there fires break out, like especially during the winter, like heater catches something on fire and all that, and it catches something flammable and it flares up like crazy. It turns out that a lot of that flaring from flames, it's is great due to gravity, because of the gravity. Um, the pressure, it changes. The gravity is pretty much what gives us our atmospheric pressure, and because there's that pressure, what happens is that when something catches on fire, all that oxygen pretty much rushes in. Why? Because what happens is that um, there's enough there's enough heat to pretty much burn it and react it with oxygen. And what happens is that that oxygen bonds with carbon bonds. Let's just say that it's burning like paper, that it produces carbon monoxide, carbon dioxide. It produces that, and what happens is where you normally had a certain volume of oxygen around that object, that oxygen is bonded with the carbon, forming carbon monoxide or carbon dioxide. And what you get left with in that area is pretty much kind of like a vacuum. Of course, it does get filled with carbon dioxide later on, but in that instant, what happens that oxygen rushes in and kind of diffuses with it with the carbon monoxide, whatever gases are being produced there. So that's what happens in that instant, and it's as it goes on burning and burning more oxygen is being used up, and more and because we have an atmospheric pressure, it fuels it and fuels it more and more and more and more. And so what I was trying to get at with the concept of manipulation of gravity, and this is assuming, of course, that if it can be done. Uh, what you would do is, if there was a way to set up a perimeter in which you affect only a certain area, and of course you would have to pretty much get everyone out of there, of course. And what you would do is pretty much within that perimeter, what you would do is pretty much like reduce gravity to like probably a tenth or even less of the current normal gravity. And what would happen is that instead of getting these huge flares and everything, what you would get is like a barely luminous flames. Why? Because there's no gravity. You pretty much affected the pressure, the atmospheric pressure, and because of that, it affects what's fueling the fire, and it might as well also like turn off the fire and all, um, turn off the fire altogether, because you wouldn't have that pressure of oxygen coming through the burnet and all. Now, the now if you there's another concept, another use for this. I'm not really sure um, if this would actually work, but let's say that you do the same gravity manipulation with the air, and instead of, how do you say, instead of like reducing the gravity, you augment it. When you light up something there, it's likely to it's probably likely to burn a lot more faster. Of course, this is considering how fast it consumes the oxygen within that particular perimeter. Uh, and and the thing is that the other thing that kind of goes with this is, it could have like another practical application in which you you can pretty much create like put a condition in which there's heat and pressure, rather than relying on like pressure valves to create heat and pressure. You could pretty much use gravity and heat to pretty much apply heat and pressure and all. But anyway, like I said, these are like only hypothetical concepts, ideas that just pretty much come to mind every now and then. But anyway, guys, thank you guys for watching. Please like and subscribe. And like I said before, pledge to my Patreon. And I'll catch you guys next time. Bye.